This video is on average atomic mass. If we look at the periodic table, we notice that the average mass, or the atomic mass listed of our elements, is a decimal. Now, we've already talked about mass numbers, and those are whole numbers, because a mass number is the number of protons plus neutrons. Here, if I were to look at beryllium, it has a mass of 9.012. Well, I couldn't have part of a proton or neutron, so that means that this number must come from something else. But in fact, it does. An average atomic mass, the number found on the periodic table, is actually a weighted average of all existing isotopes by percent abundance. So scientists have done experiments that have figured out what are the different isotopes and the percent abundance of those isotopes, and that has led us to find this average mass. So if I were to scoop up an amount of an element, the average mass would be about this based off of how many of each isotopes are there. We remember that isotopes vary their number of neutrons, and because of this varying number of neutrons, they have different mass numbers. We can also write isotopes using isotopic symbols. You'll notice this happens as we talk about average atomic mass today. An isotopic symbol is where we write the symbol of our element and then a dash after it and the mass number of that isotope. This is useful when doing average atomic mass problems. A weighted average. A weighted average is something that you have seen before, usually in figuring out your final grade of chemistry. A lot of time classes are set up where your final grade is 40% of your quarter 1 or your first term, 40% of your quarter 2 grade or your second term grade, and then you have a final exam that's worth 20% overall. So let's say we have a pretty solid B student. In quarter 1, she earns an 85% for her final grade. In quarter 2, things got a little harder. She worked, but she got an 82%. On her final exam, she earned an 80%. She wants to know, what is her final grade going to be? Well, to figure it out, she needs to make a weighted average grade. Here, she takes the percent applied to it. So her first term grade was 40% of her quarter 1 grade of an 85. She adds to that her second quarter grade, so 40% of her quarter 2 grade of an 82, and 20%, these should just be the numbers, and 20% of her final exam grade, which was an 80. Because these are percents, we get an answer of 40 times 85 plus 40 times 82 plus 20 times 80 to be 8,280. Well, I know that's not a percent or a score she's going to have, and that's because my percents were listed as percents and not as decimals. So to change a percent to a decimal, I divide by 100, and that gives me an overall score for my final grade of an 82.8%, or an 82.8 as my grade. This same tactic is used when we figure out average atomic mass of our different isotopes. Here we have rubidium. Rubidium has two common isotopes, rubidium-85 and rubidium-87. So rubidium-85 and rubidium-87. The abundance of rubidium-85 is 72.2%. And the abundance of rubidium-87 is 27.8%. I want to know my average atomic mass, so I need a weighted average of my two. That means if I have a sample, 72.2% of my sample is rubidium-85, and 27.8% is rubidium-87. So I want to figure out what's the average, and take into account that most of it is rubidium-85. I take my 72.2% of my mass of rubidium-85 plus my percent abundance of my rubidium-87, and I get 72.2% times 85 plus 27.8 times 87. I get 8,555.6. Well, I know that can't possibly be it. It's a mass because it's crazy big. And I realize, oh, I use percents. So I need to change my percents into a decimal. So I divide by 100, which gives me 85.556 as my atomic mass units, AMU. And I check my sig figs. Percents, that's a calculated number, not measured. So that doesn't factor in. So I have to go back to my measured values, which were my counting of my protons and neutrons, my mass number. That leaves me with 2 sig figs, so I get an average atomic mass of 86, and my units are AMU, atomic mass units.